Hello everyone, my name is Artem and today's lesson is all about incredible two-pointers technique. If you're interested, let's get to it. Before we'll start digging into technique, I wanted to tell you about the benefit. Why should you use it? Basically, two-pointers technique allows you to improve performance of your solution from n log n or n square time complexity to linear time complexity, and this is the benefit. To understand two-pointers technique, you should be already familiar with the basics of data structures like array and linked list and master B connotation. So if you feel like you may need to ramp up a bit your understanding of B connotation, you can watch one of my latest video about this topic. Two-pointers essentially involve having two variables whose values represent addresses in memory. Alternatively, values of pointers can be equal to indexes of an array. So let's take a look how arrays looks like under the hood. Here we can see that I have created a variable which is equal to Artem codes, domain of my website, and in Golang, each element of the string, it's basically an element of the array with type 8-bit unsigned integer. And here the representation of it. Each element has own index, starts from 0 and so on. Value, here represented as letters, but unsigned integer it will be numbers. Just to make it more easier to read, I made it like letters. And then we have addresses in memory. So this is like how array looks like under the hood. And on this figure, you can see how pointers look like under the hood. We can have left and right pointers, and the values of them refer to addresses in memory of elements with index 0 and 4 of array S. So here is the representation. Left address is 1000 and right is 1004. And it means that if this value will be changed, for instance to B, by this address we'll be able to get the latest version of this value. So it means B. The same with the right pointer. And these variables left and right, which are pointers, allow you to track the state of two elements at once during the iteration through the collection. And they usually called as left and right or fast and slow, and usually applicable only to linear types of collection like linked list and array. If you're interested why they called left, right or fast and slow, stay tuned. Alright, let's move on to practical part and solve some two tasks from the lead code. So here is the description. Given one indexed array of integers, numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers index first and numbers index second, where index first bigger or equal to 1 and index second bigger than index first and less than number of elements in the array. Return the indices of these two numbers, index first and index second, added by 1 as an integer array, index 1 and index second, of length 2. These tests are generated such that there is exactly one solution. You may not use the same element twice, and your solution must use only constant extra space. Quite complex the description, but we can see here a few examples, and let's have a look. So here we can see two input parameters, which are array of numbers and target. So target is a number that we need to find, and numbers, it's the two numbers which are in sum should be equal to the target. So here, for instance, it's 2 and 7, and we return 1 and 2. Why? Because we return their indices. So it's kind of index. We remember that the first index is 0, the second is 1, but we add 1 to each of them. So instead of 0, we're getting 1, and instead of 1, we're getting 2. So due to this, output is 2, because 2 plus 7 is equal to 9. Right? Move to the next one. Here is 2 and 4, and index is 0 plus 1, 1. Here the index is 2 plus 1, 3. So we return the array of 2 elements with values 1 and 3. So this is a gist of it. And yeah, same works for other sums. Okay, and in case we don't have cases where we'll not have a match, so anyways in the result we'll get the target, we'll find the target, but we can return just nil in case we didn't get it, just for in case. And that's mainly it. Let's solve this problem by first approach. The first approach by which we can solve this problem is the brute force. So let's say we have the following array as an input and target 6. So we can check it with 2 nested loops. So we'll check pairs by the following way: check 2 with 3, then 2 with 4, and we found target. And this approach will work. We'll find target eventually, but it's quite slow, and with 10,000 or 100,000 of elements, it will be much slower than approach with 2 pointers. And we'll check it practically. So let's say I will execute the benchmark which I have prepared. Here all of them have a function for generating such arrays and different benchmarks. So here we can see the result of them. So for 10 elements, it took such number of iterations, which is great. As bigger number of iterations is better. And we can see that with each increase of elements in the array, we're getting smaller and smaller number of iterations that we were able to get. And operations take more time with each increase of size of the array. And we can solve the same problem, but with slightly different approach, using 2 pointers technique. Let me open another example. Here we go. Here's the solution. I'll explain how it works in a second. And here there's the same test for benchmarks, same function basically. And let me open one more window to be able to compare them. Here we go. And we can see that number of iteration remains almost the same. It's decreased, but not dramatically, because we have linear time complexity here. The time how long each operation takes is not that bad, and increase linearly, which is great. So as far as we have seen the difference between brute force approach and 2 pointers technique, let's dig into details of the solution with 2 pointers. So let's assume that we have this array as an input and target, and we'll be solving this problem by 2 pointers. So first of all, we need to create them. The first pointer, which is left, is equal to the first index of the array. and the right pointer will be equal to the index of the last element of the array. And we'll check this pair first, check the sum of this pair, which is 12. 12 is greater than 9. Logically, we need to move the right pointer on to the left, so decrement it. Now we'll be checking 1 with 10, still greater than 9, decrement it. 7 and 1, smaller than 9. Now we need to move to the right or increment our left pointer. So in the next iteration we're checking 3 and 7 pair, which is equal to 10. 10 is greater than 9. Again, we decrement our right pointer. 3 and 5 is equal to 8. Increment the left one. So we end up with the result 4 and 5 equal to 9. And we increment their indexes, like this element has index 1, 0, 1, 2, so incrementing is to 1, getting 3, and this has index of 3, incremented to 1, getting 4. So we've got this pair. Let's see how it was implemented by the code. So we created the left and right pointer, as I mentioned, the first equal to the index of the first element of the array, which is left, and the right equal to the index of the last element of the array. And while left index or pointer smaller than right pointer, we iterating, checking the sum. If sum equal to target, that means that we reach the target, and we adding +1 to the left and +1 to the right, because it was required in the task description. In case our sum is smaller than target, we increment the left, and in case our sum is greater than target, we decrement the right. And that's mainly it. I hope this was clear to you. Okay, and I would like to encourage you to master fast and slow pointer technique by yourself. And as a great example, I would like you to provide the following task. The number is 876 on the lead code. The name is middle of the linked list. I think it's quite great problem to master two pointers technique itself, and especially fast and slow. So good luck with it, and let me know if you solve it in the comments. And thank you for watching until the end. I hope this technique will help you to find optimal solutions for your problems. It was fun for you, and see you in the next one. Bye bye.